Hello students, as you all know through the thumbnail that the topic of today is motion in one dimension, and in this video we are going to discuss the terms related to motion in one dimension. Slowly we will move on to the current topic, but first we need to know what are the terms related to motion in one dimension, so that when I come to the current topic you won't have any doubt regarding what are the terms that I'm speaking with you: acceleration, velocity, rest, motion, or your vector or scalar quantity, all these terms. So I'm going to first discuss all these terms, then after that we are going to move on to the topic motion in one dimension. Simply motion in one dimension, as you would have studied in your school, that it's a straight simply it's a motion in a straight line path. But today's video is all about the terms related to motion in one dimension, and the terms that we have discussed in this video is scalar and vector quantities, and second one is rest and motion. These things may look simple to you, but according to physics it is little complicated. The rest and motion that you are witnessing in your daily life is not that rest and motion which we use in physics. So today we will discuss those two topics. So let's start. First topic is scalar and vector quantity. First one, we will discuss what do you mean by scalar quantity. So see, scalar quantity simply means a quantity which does not have any direction. If it doesn't possess any direction, that is called a scalar quantity. It means it consists of only magnitude. Only magnitude is there. For example, your temperature, mass, volume, they don't give you any direction. Example, suppose 2 kg potatoes. So for this we don't need any direction, no need of direction. It means the scalar quantity gives you a complete meaning in itself. Clear? Do not think that vector quantity is more superior to scalar quantity because it gives you direction. Scalar quantity in itself is meaningful, but what is the characteristic of this quantity is it do not possess any direction. So scalar quantity are the quantities which consist of only magnitude. They do not contain any, they do not give you information regarding any direction. As I told you, example is mass, volume, temperature, all these terms comes under your scalar quantities. Another one which you are the term that you are in a discussion from your smaller classes is distance. So distance also comes under scalar quantity. For example, if we say that regarding our city, we can say that the Gangotri is 100 km away from Uttarkashi. Clear? So we are not specifying any direction. We are just giving a distance, that the distance of Gangotri shrine from Uttarkashi city is 100 kilometers. Clear? No direction, nothing. So distance also comes under scalar quantity. I hope now you know what is scalar quantity. Scalar quantity is a quantity which possesses only magnitude and no direction. Second comes your vector quantity. Now vector quantity, just like scalar quantity, also possesses magnitude, but it also has a direction. For example, if I say that 2 kilometers towards north. Suppose I am at a current place and I'm telling you that move 2 kilometers towards north. So this time it means that you cannot go in any direction. You have to go in north direction, means direction is specified. When direction is given along with the magnitude, you call it as vector quantity. Just like scalar quantity, what you have to add extra is that there is a direction associated with vector quantity. Only that much the difference between scalar and vector quantity. And here displacement comes. Displacement is a vector quantity. Suppose this is a person A and I give this instruction to this person A. So now A will displace 2 kilometers towards north. So it means here displacement is a vector quantity. But if I say distance, distance does not contain any direction. So we say that distance is a scalar quantity, whereas displacement is a vector quantity. So this is the definition, and in this way you can explain it in your examination. Orally also you can explain that scalar quantity has a magnitude and no direction. Example, distance. Vector quantity has a magnitude as well as a direction. Okay? So this is your scalar and vector quantity. Second point that we are going to discuss is your rest and motion. A very important part, a very important topic in motion in one dimension is rest and motion. Now how to say whether something is at rest or is at motion? For this, in physics what we do, we take a reference point. In the ICSE books the term used is your immediate surrounding, but better than that you can use the word reference point. Reference point means a point to which you are referring in respect to a particular body. For example, if I have taken, you can take any reference point. You can take table as a reference point. You can take tree as a reference point. You can take another person as a reference point. Reference point is not a special point, not a particular point. You can take any reference point. For example, suppose this is a person A, named A, and here is a tree. Okay. Now this tree I have taken as a reference point. Do not use RP in your examination. This is not a standard abbreviation. Just for our understanding, I'm using it in a small way, clear, in an abbreviated way, R dot P dot, clear. So a reference point is this tree and this is A. Now I want to check whether this person A is in rest or motion. So what I have to do is I have to take some time interval. Suppose after 5 seconds I notice that with reference to this point A is here now. Now A is here. Then I will say that with reference to this point A is in motion. A is in motion. Why? Because it has changed its place with reference to this tree. In this way we judge in physics whether a particular given thing is in rest or motion. If with respect to the reference point the position of given person or a given material, whatever it is, if it changes its place with reference to a reference point, with respect to a reference point, it means that it is in motion. But suppose the condition would have been different, like after 5 seconds when I checked the position of A, I found that A is still at the same place. Now this is another situation. Earlier A was somewhere here, as I showed you in the diagram. Suppose after 5 seconds I checked and I found that A is still at its current position, which was earlier. Then I will say that A is in rest. A is now not in motion because A has not changed its position with respect to the reference point that we have taken. So in this way we are going to specify, we are going to judge whether a given body is at rest or is at motion. Let us take another example. This time I will take two objects together. Suppose I'm taking reference point as tree, and here I take A and here I take B. Now suppose after 1 minute, after taking a time interval, I checked the position of A and B. I found that B is still at its place. B is still at its place, but A is now here at this point. Suppose I mark it as A dash. The previous position of B was here only and current position is also here only. For A, the previous position was here. Now the new position is at A dash. So what I am going to conclude from here is, I will say that A is in motion. How I got to know? With the help of this reference point. Clear? And I will say that B is at rest. Why B is at rest? Because with respect to this reference point, B hasn't changed its position. So I will say that B is at rest, but A is in motion. I hope it is clear how to justify. But suppose they ask you the definition, that when will you say that a body is at rest or a body is in motion, then how you have to give the definition is, you will say that when a body changes its place with respect to a given reference point, it is said to be in motion. But if a body does not change its position with respect to a reference point, then the body is at rest. Simple definition, and you can give this diagrammatical representation you can give in your examinations. Clear? So definition, I hope it is clear. When a body changes its position with respect to a reference point, then motion. If a body does not change its direction, its position with respect to a reference point, then it is at rest. Now see the beauty of physics. Here I will show you something. Same body I can say it is at rest, and same body I can say it is in motion. For example, I can prove that A is at rest, and I can also prove that A is in motion. How is it possible that same body is at rest and same body is at motion? That is only and only because of a reference point. That is why I said to you that rest and motion is a different concept in physics. It's not according to the normal life. Clear? So let's take, how can we prove that A is in rest? A can be at rest and A can also be in motion. See, suppose I'm taking that person A and I'm taking a person B, and both of these are in a train. Suppose they are traveling in a train. A and B or a person, they are traveling in a train. So again I take a reference point. Again I take tree as a reference point. Do not think that why always I'm taking tree. You can take anything. Suppose I'm taking a box which was outside of a tree. Let us now take a box. So with the reference to this box, if I say something about A, when the train is moving, I can say that A is in motion. Why? Because with reference to this box, this A is going to change its position. Definitely the train is moving, so distance will change between A and the box. So I can say A is in motion. But if I take reference point now B, right now if I take reference point as B and now I check whether A is in rest or motion, then I will get an answer that A is at rest. In this way these two things are different. Okay. Same body is at rest, same body is in motion. Many of you would be confused that what I am teaching. That is just on the basis of reference points. If the reference point is box, then A is in motion. If the reference point is B, A is at rest. Why? Because every time you will check the distance between A and B at any point of time, what you will notice, distance is not changing, position is not changing when the reference point is B. And when the reference point is the box, then the distance is changing, position is changing. So I will say A is in motion. So that is what I said. Same body can be at rest, same body can be in motion, but it depends on the reference point taken. Clear? That much is the importance of reference point in physics. I hope now it is clear how to define rest and motion. But if simple question comes that when a body is said to be at rest, as I told you, you can say that a body is said to be at rest if it does not change its position with respect to a reference point. And as I told you, reference point can be anything. So this is how rest and motion is defined in physics. So these two terms were important terms. After this also we have some more terms that we'll discuss in the lecture number 2. So from this video, what you have to clarify today is, you have to clarify what is scalar quantity and what is vector quantity. Second point, you have to specify, you have to clarify what is rest and what is motion. Simply do not give definition of rest and motion according to your daily life. With reference to, according to the physics, you have to give the definition. And for rest and motion, always remember your definition is incomplete if you are not using a reference point which is written as immediate surrounding in your ICSE textbooks. Clear? That immediate surrounding is also a reference point. With immediate surrounding, you are changing your position, means you are in a motion. If with that immediate surrounding you are not changing your position, it means you are at rest. So in the physics it's immediate surrounding, but it will be more better if you try to use reference point. So I hope these 2 points are clear to you. Clarify these 2 points, and in the next lecture we are going to come with some new points, some new terms that are related to motion in one dimension. After those terms we will move on to the motion in one dimension, straight topic. Again I'm telling you why I'm teaching you these terms, because when I will use these terms in motion one dimension, now I hope when I tell you that this is a scalar quantity, suppose I say a sentence that this particular thing is a scalar quantity, now I won't have to clarify you that what is the meaning of scalar quantity there. From here you know that if sir is saying it's a scalar quantity, it means this particular quantity is going to have only magnitude, not direction. So this is the importance of first clarifying the terms. So I hope you will clarify these 2 terms today, and in the next lecture we are going to come with new terms related to motion in one dimension. Till then, keep growing, keep studying. Thank you.